Welcome to the Agronomy and Farm Management Podcast. I'm Amanda.
And I'm Elizabeth. Thanks for joining us today.
Soil sampling is something that most farmers have started doing in recent years to better manage their yields and crop inputs. So most of you are likely familiar with the basics of what nutrients are analyzed from a test and how samples should be pulled. But today we want to do a refresher on why consistency is important in pulling your samples, how we interpret results, and if this dry weather we've had recently has any impact on those sample results. So today we've got Greg Labarge joining us. Greg, could you take a second and introduce yourself to our listeners?
Sure, be happy to. Greg Labarge, field specialist in Agronomic Systems with Ohio State University Extension. Been with Extension for about 35 years. The past 10 years been working in nutrient management and some of the water quality issues we have here in the state.
Awesome, Greg. It's great to have you joining us today. Soil science is an area that you've got a lot of knowledge and expertise in, so we're excited for you to share that with us today. Could you start off by just kind of giving us an overview of why consistency in pulling samples is so important?
Yeah, consistency is pretty important because, simply we're taking a very small amount of soil and we're sending that into a lab that's going to take a very small amount of our sample and actually do the analysis on that. So the ideal of being consistent in collecting our samples is really important because that tends to be where the error is the greatest, is in that sample collection process. So controlling sample depth is really critical. Controlling the time of year that we're taking that sample are really two key things that we want to be thinking about in relationship to soil sample collection. I guess the other thing that we want to do is not forget that, sometimes we'll have a bad core, and rather than putting that bad core in the sample, we probably ought to pull one next to it, just so that we're getting good samples, getting good representation of the field, and getting that in place. Probably the area that we talk the most about, and we have maybe the greatest amount of uncertainty, is how to divide up a field in relationship to collecting a sample, because we know that nutrients, every core that we take is going to be different as far as the nutrient concentration based off of past practices. So, whole field tend to be around 20-25 acres is the max there. But then we start whittling things down and getting to smaller acreages and areas based off of what we know as far as variability out in the field. And really often we'll need to, do some either grid sampling, zone sampling, try and break those fields down to a finer scale before we really understand what kind of variability we have out there and what future soil sampling needs to look like. Then consistency also is important as we think about, taking samples from here in 2022 and then comparing those to samples we take in 2024. Really that trend and what's happening in there from a nutrient standpoint, how nutrient concentrations are changing. Does that match up to our fertility program? That's all a part of what we need to be thinking about as we think about adaptive management, where we're, all systems are different and we need to be thinking about how we manage nutrients in those different systems.
I want to back up to something you said a little bit ago about if we pull a bad core. So what would a bad core look like?
Yeah, sometimes we're taking a 0 to 8 inch cores, typically 0 to 6 inch core is an alternative. Our tri-states are based off of a 0 to 8 inch core, but sometimes we'll push that probe into the ground and it will compact. And we're not sure whether we're getting a 4-inch sample or a 12-inch sample because of the compaction that's occurring within that. So rather than throwing that in the bag, we ought to throw it on the ground and go, within 6 inches or so of where we pulled that last core and get a new core so that we get that representation for the depth of the sample that we're taking.
And you mentioned about trying to identify variability in the field with our different types of sampling, whether it might be zone management or grid sampling. So then what do we do with that variability once we've identified it? When is it important to adjust recommendations, or how do we move forward with that?
we can go across the field and, in some cases we'll find out that it's, for phosphorus, we're looking at a range of 20 to 40 parts per million, Mehlich 3 soil test. And if we see that in every zone that we have, then we don't have any inconsistencies out there really to manage for, as long as we're hitting that sweet spot. It's when we have sample results that are lower than that soil test, below 20 parts per million, because that is an indication that we need to apply phosphorus in order to reduce risk of yield loss. And then if we're higher than that 40 part per million, guess what? We got some free nutrients out there. Let's take advantage of what somebody put in the soil bank, and we can withdraw from that account.
So when you get your soil test results back, there's a lot of information that it provides. And we could spend probably 5 podcasts talking about the information that we need to know to get through one of these. But could you give us just a high level view of what's most important when we're looking at our soil test results?
Yeah, actually, there's 2 key numbers that have no relationship to the nutrients that we have in the soil. One of those is the cation exchange capacity, and cation exchange capacity gives us an idea of the holding capacity of that soil. It's most of our soil sites are actually negative charged, and many of our nutrients are positive charged. And so in cation exchange capacity, what we're accounting for is actually the negative charges on the soil. And that gives us the amount of nutrient that we can hold within that soil. Our sandy soils, we tend to have a low holding capacity. Our clay soils, we tend to have a much higher capacity and can hold more nutrients before we worry about leaching. The second number is the pH, and pH is important, and it would be the water pH that we want to be looking at, because that's going to help us understand the availability of nutrients. As long as we're in like 6.3 up to a 6.8, we maximize the availability of most of the nutrients we have in the soil system. And so we want to be in that area with that pH. So those are kind of 2 key numbers to really give us a background and understanding of what kind of either soil type that we have with cation exchange capacity or pH, what nutrient availability is. The third number that ties into pH is the buffer pH, and that buffer pH, what we're doing is trying to understand how much lime we would need to apply if our pH is out of whack. And so that gives us a capability to calculate how much lime we want to add to the soil.
This, I think most farmers and those in agriculture understand this, but it is a question I get quite frequently with home gardeners expecting to have nitrogen on there. And that's one number we don't see. What is it really about nitrogen that makes it, unless you have a specialized test, it won't show up on our normal soil tests?
Yeah, basically nitrogen is pretty slippery in the environment. It is changing forms frequently based off of soil condition, and it's hard to hold in the soil. While it's just that paradox that we have 78% of the atmosphere in nitrogen, we really can't hold that much of it in the soil unless it's in an organic form. We can temporarily hold it in the ammonium form. Depending on what fertilizer we have, that may be the predominant form. And then the nitrate form we know will leach and denitrify, go back into that gaseous state and be lost. So we don't do much with soil test unless we're in season, close to when we're actually thinking about applying nitrogen before we think about a soil test for nitrogen management.
So 2 of the results we see on that test are for the nutrients P and K. And we use this information to make our fertility decisions on the farm. And we've been getting a lot of questions coming in this fall with the dry weather. Can we trust these soil samples that we're pulling and the results we're getting back? What information can you provide us about answering that question?
Yeah, absolutely. And let's talk about potassium first. Really, potassium is one number that we will see variations on. One factor in that variation is reality that we have with like a 200 bushel corn crop, 60 bushel soybean crop. In that residue, we have about 80 pounds of potassium, K2O. And that in a year where we have moisture in the fall, will actually leach out most of that in a soybean crop and about 50% of that in a corn crop. So we are picking that up in the soil test when we go out and collect that, as long as we've had 5 to 10 inches of rain since the crop has finished its growing season. So one source of variability in this dry weather condition is just the idea that it's tied up in the residue still and hasn't been released. With that 80 pounds of K2O, we think about, somewhere around 8 to 10 pounds per part per million of soil test change. And so if 80 pounds is tied up, we're going to potentially have 10 part per million difference in soil analysis just off of that. Then with our clay minerals in our soil, we can have fixation, and it's kind of somewhat reliant upon what our soil test level is. At high soil test levels of potassium, we'll actually see that we're underestimating what is available for that particular soil test level. And a high soil test would be something around 140 to 180, somewhere in that neighborhood would be on the high side. On the low side, we'll actually overestimate the amount that is available because of fixation within the soil. And it's just a characteristic of the clay mineralogy that we have in this region of the country. From a pH standpoint, depending on what the lab is doing, if they're using, we talked about it earlier as a water pH, but some labs are actually using a salt pH. And when we think about or using salt to make that pH measurement, and when we have that situation, it's good because most of our fertilizers that we apply are salts, in that then they're getting dissolved with that mixture and not affecting the pH reading. And then the lab will adjust it to a water pH. As long as they're doing that, we don't have to worry too much about the pH. But if they are doing straight mixing water with the soil, making the pH measurement directly, then we'll see maybe 0.1 to 0.4 units lower or pH than what we might have been expecting off of past samples. And I think that's kind of important too, is when we start looking at trends in samples, we probably shouldn't go, just last year or last time soil test, comparing it to this year's soil test. We probably ought to be taking a look at 3 or more soil sample periods and looking at trends in that time frame to see what we're seeing as far as variability. I mean, reality is that soil tests do vary from time to time, and we just can't always replicate how we're collecting that soil sample because of past practices. The ideal that we're doing maybe more band placement of fertilizer, using starter fertilizer that's also a band. If we hit a couple of those in a sample, it will throw off what we might see as far as results compared to a previous period.
Yeah, it all goes back to, like you said, a tiny little amount of soil representing however many acres you're sampling with. But it sounds like there could definitely be some impacts, but not an extreme amount. I mean, 10 parts per million, it may change your recommendation a little bit, but if I'm remembering correctly, the potassium recommendations in tri-states are a little bit wider range than that.
Yeah, kind of the range for potassium is somewhere between 100 to 170 parts per million. It kind of depends on where you're at in relationship to that critical level. 110 all of a sudden becomes 100, or where we definitely need to apply fertilizer in relationship to making sure we aren't risking yield loss.
We can certainly compare them to past soil samples. What if someone's on a new farm and they only have a year to compare it to? What would be your recommendation in that case?
Well, in that case, I would be conservative in what you do. I mean, reality is our biggest factor in yield response is always going to be water. We can do a few things to offset that with nutrients, and then tenure on the land has to come into play too. So if we know we have this for a long term, then we can maybe just be just a little bit freer in how we look at the nutrient recommendation. But if it's a year-to-year type of lease, then for sure we want to be conservative in what we do from a nutrient addition standpoint with a new field. Pretty quickly you'll get to understand that field with yield response, and really that's the place to go in thinking about nutrient management, where to pull soil samples, how to divide up that field, because ultimately that's what we get paid for, is the number of bushels that we are gathering through the combine and selling at market.
Yeah, that's some great advice.
Greg, you've got some research that you've been conducting, looking at some long-term plots and doing some soil sampling. Do you want to share a little bit about what you've learned from that work?
Yeah, we have some long-term plots, and when I say long-term, we've been managing these since 2006, and we've been managing it under three different scenarios. One where we're not applying any fertilizer, and we haven't applied any P and K on those plots since 2006. Second is where we're applying a crop removal rate of P and K, and then we're doing a 2.5 times the rate of crop removal in that third set of plots. And really, let's speak to the plots where we haven't applied any fertility, because they're probably most interesting. What we're seeing there as far as soil tests have dropped, but they've dropped not to zero. Really, they're maintaining either between 10 or 20 parts per million, and 20 parts per million on phosphorus is our critical level at that level since 2006, with no fertilizer application at all. So it speaks to the ideal that we do have a lot of buffering capacity in the soil with phosphorus. And then the same could be said for the potassium, is that we don't drop to zero. We do have a continual release of nutrients from the soil itself, but we and our fertility additions are just spiking those soil test levels up. The site that has had the most yield response is actually the western site here near Springfield. And so these soils down here seem to be ones that we can lower that soil test and lower it fairly quickly. So we want to be more conscious about our nutrient management programs with these Miami soils and like that are in this area.
Due to a lower clay content compared to the ones up north?
Probably that soil type differences is probably the primary thing that would account for that. I guess maybe a final thing that we can talk about is just when we talk about phosphorus, and sorry, we talk about that all the time, and where I'm at, we're thinking about it from both the crop production side and then the environmental side. We can think about these soil tests, and particularly the P soil test level, in relationship to an environmental sensitivity. And once we're getting soil test levels that are above 100 parts per million, and it won't be a whole field, it's just going to be a portion of the field that's going to be at that level. That's where we see really an increased risk of P loss in relationship to DRP and some of the sensitivity that we have in Lake Erie or going down the Ohio River into the Mississippi and ultimately into the Gulf of Mexico. So if you have those fields out there, they're going to remain high for a long period of time. And so we need to think about other practices besides simply nutrient management. That's where we can start to identify water management and filtering type of conservation practices that we can put in place. So soil tests are very important from an agronomic perspective, and we also have some opportunity to use it from an environmental perspective.
Yeah, that's great to know, Greg, and something we all need to be doing our part to reduce those nutrients that are going into our water systems. So we appreciate having that information. If people are interested in following up with you on some of these topics or research projects, what are some ways they can get in touch with you or resources you have available?
Yeah, probably, from a direct contact, labarge.1@osu.edu is my email address, and that's probably the best way to get to me. We also have on the Ag Crops team website, agcrops.osu.edu, a soil fertility page, and we've actually been updating a lot of the fact sheets here recently because of the changes to the tri-state in 2020. So there's a lot of resources there about interpreting soil tests, taking soil tests, and then making recommendations off of those soil tests with the tri-state recommendations.
Awesome. Well, thanks so much for your time, and we're glad you could be a guest with us today.
Thanks.
Thanks for listening to the Agronomy and Farm Management Podcast. Join us again in 2 weeks for our next episode.
Hey, podcast listeners, just a reminder to give us a like or subscribe so you know when we release new episodes. If you're enjoying the podcast, be sure to leave us a review also. We appreciate the comments.